Hello everyone, myself Prashant Ronad, first year, studying BE in Computer Science at RV College of Engineering, India. My topic is to leverage HPCC systems for natural disaster management in Asia. Introducing the topic, natural disasters like earthquakes, floods, and wildfires are sudden destructive events that significantly impact human life and infrastructure. Analyzing historical data to identify high risk areas and susceptible populations allows experts to predict future scenarios. We leverage these insights. Decision makers can implement data driven policies, resource allocation, and preparedness measures to minimize calamity damage and maximize lives saved. This is the strategic and proactive approach which is critical. In this project, we have three objectives. The first one is to analyze key disaster parameters using techniques like normalization and deviation to generate comparative severity and seismic efficiency indices. And the next one is to create visualization mappings over these indices over geography and time to uncover the trends and patterns. And the last objective is to use basic linear regression and logistic regressions to predict the future data. I have used the dataset of natural disasters in countries of Asia from 1953 to 2022. This contains the data of magnitude, life saved, life injured, damaged in USD, deaths, CPI, and many more fields, and it has almost like 11,000 records. Coming to the methodology, first we implement the ATL pipelines to prepare the raw disaster for analysis, and then we conduct the rigorous analysis of key disaster using specific indices like using normalization techniques, etc. And then we generate the intuitive visualization of temporal performances indices and monthly deviations and other matrices. And then we rank our geographic regions according to these attributes. And then we create this thematic choropleth, which we can see here, by using these ranks. And then at the last step, we build basic predictive models using linear regression to predict the number of homeless people and to predict appeal factor using logistic regression. As we, after doing all this methodology, we find the following results. China was identified as the highest disaster risk overall. Macau was identified as the safest, and Japan was endured the worst earthquakes. As we can see in this choropleth, the China has the darkest color. It means it has more disasters comparatively. We can ask that why not Japan? But Japan has less droughts compared to China. As we consider all the type of disasters like droughts, floods, earthquakes, everything, we come to a conclusion that China had it more. And then time series analysis revealed that February was the most unpredictable month across disasters with maximum deviation in the number of disasters. And coming to Qatar, it demonstrated the highest community preparedness index of 80%, which indicates that it had strong public awareness and readiness. China China also exhibited the maximum seismic efficiency index. It had over 203 total earthquakes with 5.9 average magnitude. Then our linear regression model predicted about 0.70, like we got an accuracy of 70% to predict the number of homeless people. I also created a Roxy query for this. Like if we entered the five parameters like CPI, damages, affected people, injured people, and total deaths, we can come to know the number of people who lost their homes. We can also predict other factors like total deaths and CPI by shuffling these. And next comes the appeal factor. The appeal factor is whether the country asks the help of the different organizations worldwide to minimize the effect of the disaster. It indicates the severity of the disaster. We can predict if the country had asked or not, that it is a binary value using this logistic regression. which gave an accuracy of 88.11%. So finally, using these HPCC systems and ECL language, we can manipulate this large record set of 11,000 records to visualize these chloroplasts, graphs, and to do machine learning easily on this large data set, which helps policymakers to make their decisions accurately. Thank you.